Okay, so the very first one. The addition property basically says that if I start out with A equal to B, if I add the same amount to both sides, it stays the same. So A plus C equals B plus C. If I add the same amount to both sides. All right, an example. Don't write this down, because then I'm going to erase it, because I'm going to use the same spot over and over again. If I had x minus 3 is equal to 5, how would you solve for x? Are you adding 3 to both sides? So you're using what is known as the addition property of equality, because you're adding the same amount to both sides and then keeping the equation the same. Okay? So like I said, you've used it, you just never called it that. Okay? All right, so based upon that, the subtraction property of equality, what do you think that one would be? Very good. A minus C equals B minus C. Okay, you're subtracting the same amount to both sides. Again, if I went up to my example, if I had x plus 7 equals 10, how would you solve for x? Subtract 7 from both sides. Very good. You got the idea. You're subtracting the same amount to both sides. That's the subtraction property of equality. All right? Multiplication property of equality. How about somebody else? Chris, what do you think?
Okay, it's A. It's going to be A divided. Oh, wait, would it be A divided by?
Well, what does this word mean? What is
Multiplication?
multiplication? So what are we doing?
Use multiplication to solve it, right?
So how about we multiply by C, and then if we multiply the left side by C, we have to multiply the right side by C.
Yeah.
Okay? So you're multiplying both sides by the same amount. Again, in the interest of using an example, if I had x over 3 is equal to 8, okay, how would I solve for x? Multiply both sides by 3 and you get x is equal to 24, okay? All right? Divide, division property. Cameron, what would we do? C divided by A.
Do we divide by the reciprocal?
Okay. Basically, Casey, we should be dividing by the same amount. Hint, hint, hint. Let's use the letter C somehow. Casey?
A over C equals B over C.
A over C equals B over C. We're doing dividing by the same amount. So if I had, say, 2x is equal to 14, I would divide by 2 and divide by 2 to both sides. Okay, I'm dividing by the same amount each time. The big thing that they'll put on here, just FYI, reminder, C cannot equal 0. Why can C not equal 0? Does anybody know? Trivia question here.
Because everything,
Anybody know why? Because it's impossible to divide by 0. If you typed in divided by 0 on your calculator, it's going to say error. You're not allowed to divide by 0. Okay? So therefore, you can't divide by 0. All right. Substitution property of equality. Okay? All right. So what this is basically saying is if A is equal to B, they are interchangeable. They're the same amount. Okay? So that means if I had, say, A plus 10, well, now I can replace the A with a B and say, oh, that's equal to B plus 10. So it looks a lot like the addition property of equality, but we're actually switching. We're changing the A and the B. Okay? And we'll talk about when we're doing that later on. All right? And then the distributive property of equality, you should be familiar with this one. Okay? We are, distributing the A to both the B and the C, so A times B plus A times C. Okay? All right, questions? All right, so the first thing we're gonna do is we're just gonna be given a property and you have to recognize what it is, okay? Or you have to be able to use it. So, for example, they tell us that the addition property of equality says that if x is equal to 3, then 14 plus x is equal to what? 17. How'd you get 17? Well, we're not substituting because we're adding. You're not adding 3. What did we add? Anybody know? All right, so what you want to do, okay, to help you out is you want to compare this side and this side. What changed?
The X.
No, there's an X on both of those. There's an X and an X. What did we add to the part on the right? What? No. All right, look. This is what I'm saying. Ignore the 3. I don't care about the 3. I don't care about the other side. I'm only looking at X, and I'm only looking at 14 plus X. What did we add to both sides? Yeah. We added the 14, so we're adding the 14, and so that's why Angel said 17, is because if we added the 14 to the X, well then we're going to add the 14 to the 3. We're going to add 14 to both sides, okay? So that's why it's 17, okay? What don't you like? This? Yeah, well, that's true for a lot of people. All right, so substitution property of equality says that if A is equal to 45, that means I can substitute 45 for A. What do I get? 135, very good. Okay, 3 times 45 is 135 degrees. Okay, multiplication property of equality. It says that if angle A is equal to 20, well, what am I doing to go from 20 to 80 using multiplication? How do I get from 20 to 80 using multiplication? Times 4. So if I am multiplying the right side by 4, I better multiply the left side by 4. So this is just simply a 4. Okay? 4 times the measure of A is equal to 20 times 4, or 80. Okay? So think about what they're telling you to do, and then just do it. So like if they tell us to add 14 to the X, add 14 to the 3. If they say to take 20 and multiply it by 4, take the A and multiply it by 4. Okay? All right. Maybe these will be a little easier. Okay? Here is what you got to think of. How do I go from here to here? What am I doing to both sides of the equation? What's happening to both? All right, you're multiplying. So you're using what is known as the multiplication property of equality. And you can abbreviate, okay, property, prop of equality. Okay? All right, so notice, he noticed that we're multiplying both sides by 2. All right? The middle one, second one. X plus 7 is equal to 15, x is equal to 8. So the question is, how did we go from the left side to the right side? Like over here, we multiplied by 2 to go from the left to the right. So what are we doing to go from x plus 7 to just x? We're not adding. What did we subtract? Very good. So we subtracted the 7 from the plus 7. That canceled out. We subtracted 7 from 15, and we got 8. So we essentially used the subtraction property of equality. Okay? All right? Then the third one. If z minus 3 equals 20, then z equals 23. How do we go from this equation to solving it?
Add 3.
We added 3 to both sides, so we use the addition property of equality. Are we getting the hang of it a little bit? Okay, so you always just got to think of how do I go from one step to the next, okay? All right, so this one, if b equals 2, so we already know that b equals 2. We already have that solved. And b plus 4 equals 6, then 2 plus 4 equals 6. What did we do from here to here? What changed from here to here? From the b plus 4 to the 2 plus 4.
Distribute.
Try again. Distributing has parentheses. Ooh, there we go. We substituted. The b got changed to the 2 because b is equal to 2. We substituted in the 2. So we use the substitution property. Okay. All right. Next part is going to deal with the concept of a proof. So we're going to do proofs pretty much for the next 3 chapters. We're going to do them here. These will probably be the easiest ones you do. Okay, and then in the next chapter they get a little trickier with parallel lines. Okay, and then they get a little bit trickier when we get to proving triangles are congruent. Okay, now the reason what we're doing in this chapter is we are starting with algebra because you know it, and we're using your algebra skills to kind of teach the concept of proofs. Okay, so we're starting with something you're comfortable with and using it to teach you. Okay, and I'll explain it as we go in terms of how it's done. All right, so the very first thing you do, the very first line is you always start with what is given to you. So in example number 3, I would start out by rewriting the equation. I would simply write 2x plus 5 equals 20 minus 3x. My reason is given. We are going to use this word given a lot. Anytime that they give you something, like it's stated in the question, okay, that's your given. We're not assuming it. They gave it to us. Okay? All right. From here, what you do is you just go through and you solve the equation. Okay? But you don't show the work involved. And I'll kind of explain that as we go. So for example, what would be the very first thing that you would want to do, and everybody could do it differently, but somebody come up with a way that they would solve this equation. What would be the first thing they would do? Angel. All right, he wants to add 3x to both sides, okay? Now, some of you do the like plus 3x thing, plus 3x thing. And what I'm going to say is, we're not going to do that, okay? That's not what the line is going to say. Instead, they are going to basically have you do that in your head and rewrite what it would look like if you had done that. Well, if you added 3x to the other side, you would have 5x plus 5 equal to 20. And what you do on line 2 is you basically ask yourself, how did I get from here to here? What property did I use? Well, what did he say that we did to both sides? We didn't substitute, we added 3x to both sides. So we used the addition property of equality. Okay? So the addition property. Okay? All right, before we go further, questions on that? Speak now or forever hold your peace. We're good? Okay, so then somebody else explain to me how you would solve. Anybody? Tyler.
Subtract 5 from 20.
Okay, so if we subtract 5 from 20, what would our new equation be? What would it look like?
5x equals 15.
5x equals 15. Okay, if you need to do that little minus 5, you can do that. It's just that's not going to be what you write on line 3. You would have to kind of do it really small and just show it. Okay, so what property are you using?
Subtraction.
You're using subtraction because you're subtracting 5 from both sides. Okay? What else would we do? Maddie, what would you do to solve for x? Okay, and so if you do that, what would you get? So you get x equals 3. Okay, and then what property are we using? The division property. Okay? And then there is an extra line. Sometimes we'll do that just in case. You just never know. You don't always have to use all the lines. So the 5th line we're not going to use. Okay? All right, let's do another one, and we'll kind of do it together. Okay? All right, so on this one, I always write down what they give us. So I'm going to do -4, parentheses, 11x plus 2 equals 80. And I'm going to say given, because they gave it to us. All right? Ideas. Let's start hearing from other people. Substitution, what do you mean?
Multiply -4 with the numbers and the.
Is that called the substitution property? You're correct. It's the distributive property. So what would it be, Mary, if we multiply through the -4? What would the new equation be?
Negative 44x plus 8.
Plus 8? Everyone good with plus 8?
No.
How about -8, because a -4 times a +2? And then equals 80. And then we would say we are using the distributive property. Okay? All right, next. Gabby, what would you do?
You're going to go ahead and add the 8 on both sides.
Okay, and then our new equation is?
Negative 44x equals 80.
Okay, and again, she already said it. We're adding 8, so it's the addition property. Okay, and Jaron, what would the last one be? Solve for x. What would you get? You don't know how to solve that equation?
Which one are we solving?
The one that's on the board, there's only one up there.
Are we doing all of that? I was like sleeping, I'm sorry.
Okay, well, we gotta work on that. Okay, Andrew. What will we do next? Okay, what are we dividing by? We divide by 44x? How about we just divide by the -44? Okay, so that would give us x is equal to what? -2. Okay, and we're dividing, so it's the division property. Okay? What do you guys think? Okay? All right, example 5. Okay, so again, concepts that you have to think about on this one. And this time, it actually uses the word given. Okay, so at the top, we're going to say that the measure of angle AOC equals 130 degrees. Okay, given. All right, our objective is to solve for x. Ideas. Now, what we have to do is we have to create an equation. Now, in order to do that, there's gonna be one line that is gonna be really, 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 really tricky. And it's gonna involve what is known as the angle property. There's an angle property that we did, like we did the segment addition property. Anybody know what I'm getting at?
One segment is in the,
But we're doing angles. Anybody? Anybody? All right, so we have to create an equation, okay? But I want to do it with all angles first. So if we wanted to solve here, what would we do? What concepts would you do? All right, let's make it easier. Solve for x. What would you do? All right, very good. Okay, so you would do x plus 2x plus 10 equals 130. Okay, now what that is going to, that's eventually going to be what we get to, but in order to do that, technically what we're doing is we're doing the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. Okay? Does any remember what that would be called? Okay, this is known as the angle addition postulate. Okay, this was given to us, I think, like one of the second or third sections of the chapter 1. Okay, so we talked about the segment addition postulate. This is called the angle addition postulate. The angle addition postulate basically says this angle plus this angle equals the big angle. Okay, that the whole is equal to the sum of the parts. All right, now what we did was after we created our equation using angles, we replaced the angles with their actual values. When you replace something, what property are we using? Substitution. So we substituted x for AOB. We substituted 2x plus 10 for BOC. And we substituted 130 for AOC. So we used the substitution property. Okay? Next, we want to solve. What would you do? Because that'll determine what we...
1x plus 2x.
All right. So 1x plus 2x would combine to be a 3x plus 10 equal to 130. Did we use the addition property of equality? No? Very good. We didn't. Why not? Ooh, I like that phrase. What did we do instead? We combined like terms. Okay? Now, let's go back to the question I asked. Why isn't it the addition property of equality? Can anybody answer that? Why isn't it? Angel? Very good. Excellent. You guys are smart. Okay? But now we're going to subtract 10 to both sides. And so now we're going to use it and get 3x equal to 120. And so now we're doing the subtraction property because we're doing the same amount to both sides. Okay? All right, and then the last step. Tony, what are we doing for the last step?
You divide both sides by 3.
And get x equal to?
40.
All right, and then that property is the?
Division property.
Division property. Okay? Questions? All right, so 2 tricky things in there, and that was the addition, angle addition postulate, and then the combining like terms was a little bit tricky in there. Okay? All right, so your homework then, you've got the next 2 pages, numbers 21 to 22, recognizing your properties, and then being able to do the algebra part of the proof. See what you can do, okay?